My dear students of 10th standard, nowadays we are discussing about carbon and its compounds. So before going to start a new topic in this lesson, classification of organic compounds based on the functional group, we have to revise whatever we learn in this chapter so far. Already we know the symbol of carbon is C and its atomic number. What is the atomic number of carbon? 6. Atomic mass 12, configuration 2,4, and carbon is a unique element which possesses the property of catenation, tetravalency and multiple bonding, which enable it to combine with itself or with other elements like hydrogen, oxygen, nitrogen, sulfur to form a large number of compounds. And that's why we used to say carbon chemistry is a living chemistry. So without carbon, the life on this earth is not possible. Then already we learned about the classification of organic compound based on the pattern of carbon chain. It is a open chain compound and closed chain compound. Further classified into saturated, unsaturated, carbocyclic, heterocyclic. Then carbocyclic further classified into alicyclic and aromatic. And also we learned about the classification of organic compound based on the kind of atoms. That is, first in this hydrocarbon means nothing but that is the compound containing only carbon and hydrogen. The carbon compound possessing carbon and hydrogen atom. Out of this there are three categories: alkanes, alkenes, alkynes. Alkane general formula CnH2n plus 2, alkenes CnH2n, alkynes CnH2n minus 2. Alkanes are compound possessing double bond and triple bond. Double bond and triple bond, these two are under the category of unsaturated organic compounds. Then also we learned about the characteristics of hydrocarbons. They are normally, the lower hydrocarbons are gases at room temperature, colorless, odorless, and when the number of carbon atom increase, their boiling point also increase. And also these compounds undergo combustion reaction to give carbon dioxide and water. They are all normally least reactive. Out of these, alkane is highly least reactive compared to the other classes, alkene and alkyne. And alkene possesses double bond, alkyne contains triple bond. And there is a test to check whether it is saturated hydrocarbon, unsaturated hydrocarbon. That is a bromine test. The bromine test, the saturated hydrocarbon does not decolorize bromine water, but alkenes and alkynes decolorize bromine water. So this is the test to identify whether it is saturated or unsaturated compound. Now we are going to study about the classification of organic compound based on the functional group. So what is functional group? Also already learned in 9th standard. That is an atom or a group of atom in a molecule which give the characteristic chemical properties. It is given here, the definition. A functional group is an atom or group of atoms in a molecule which give its characteristic chemical properties. Normally, the structural framework of the carbon compound, organic compound made of carbon and hydrogen. And this carbon and hydrogen going to give only very less, relatively less reactive in nature. So the presence of other compounds, other atoms or group of atoms make the compound more reactive. So because of this presence of other atom or group of atom, the chemical properties are going to be determined. So the chemical properties of the organic compound hydrocarbons are determined by the presence of some other atoms or group of atoms. So these atoms or group of atoms are called functional group. Functional group, because these atom or group of atom only going to define the chemical properties of the compound. So the chemical, actually there are two parts. There are two parts. You see this formula CH3, that is the hydrocarbon, basic hydrocarbon. This also can be written in the form of C2H6. C2H6, the expanded form is CH3. Also we can write some other pattern also in some more expanded form. And this is a basic hydrocarbon, also called parent hydrocarbon, that is alkane. So in the alkane, if you replace hydrogen atom, if you replace an hydrogen atom by OH group or by any other functional group, so that compound is turned to be alcohol or aldehyde or acid. So if one of the hydrogen is replaced in the parent hydrocarbon, it's going to give a different kind of compound like alcohol, aldehyde, ketone, acid, ester or ether. So this part of OH or COOH or CHO or COR, these groups are called functional group, because these groups only define the chemical property of this compound, chemical property. The remaining part, that is CH3, the remaining part, that is ethyl or methyl or propyl or butyl. So that part going to define the physical property of the compound. So there are two parts. One is functional group, other one is the remaining part of the parent hydrocarbon that define the physical property of the compound. That is given here. See, the chemical properties of organic compound depend on its functional group. Functional group, that is maybe OH or CHO, like that. Then the remaining portion of the structure going to define the physical property of the compound. Physical property. See, carbon to carbon double bond, triple bond also considered as a functional group. And there are some other examples are given. See, that is OH. OH is a functional group of alcohol. CHO, functional group of aldehyde. COOH, that is the functional group of acid, carboxylic acid. So for example, say ether is a hydrocarbon, that is a basic hydrocarbon, formula C2H6, and one of the hydrogen is replaced by OH, it will give alcohol. So leaving the functional group, the rest of the structural is represented by R. R is alkyl. R means alkyl. So we can represent using the simple formation ROH. R dash is that is a bonding. R is bonded with OH, that is R is alkyl, OH is alcohol. We can also call it as alkyl alcohol. ROH is alkyl alcohol. Maybe if it is alkyl is ethyl mean ethyl alcohol, methyl mean methyl alcohol, propyl means propyl alcohol, R is butyl mean butyl alcohol. So R is alkyl group. Then a series of compounds containing the same functional group is called a class of organic compounds, also shown in the tabular column. The various classes of family of organic compound and their functional groups are given in this tabular column. See, alcohol functional group is OH, oxygen and hydrogen combined to give like the hydroxyl group, that is attached with one alkyl group. R here is alkyl group, that is ROH. OH is functional group, R is alkyl group. That OH define the chemical property, R define the physical property. One example is given, that is instead of R, if we give the ethyl CH3 CH2, that is obtained from ethane by replacing one hydrogen by OH group. So ethyl OH, ethyl alcohol. Ethyl alcohol is a common name. Ethyl alcohol is common name. Here it is given ethanol. Ethanol is a IUPAC name. Ethanol is IUPAC name. The next one, see aldehyde. Aldehyde, CHO, carbon, hydrogen, oxygen. These three atoms combine in a group and act as a functional group, that we can write RCHO, or bonding CHO. So R is alkyl group. Suppose instead of R, if you apply methyl CH3, the methyl is obtained from methane. Replacing one hydrogen by CHO, we will get methyl CH3. The CH3 is called methyl, that is a CHO. So what is the name of this compound? Acetaldehyde. Acetaldehyde. Then ketone. Ketone functional group CO, carbon and oxygen, carbonyl. That carbonyl group is act as a functional group, and either side R is given. So two alkyl groups are attached either side of carbonyl group. That both the R may be from the same alkyl or different alkyl. So actually there are two types of ketone, that is a simple ketone and mixed ketone. Simple ketone means if both the R are from same parent hydrocarbon, that is called a simple ketone. Suppose one alkyl is from one parent hydrocarbon, the other from the different hydrocarbon, that is called a mixed ketone. Mixed ketone. And here in the example it is given, see, same alkyl group is given, that is CH3 CH3, both are methyl, same alkyl. So this is simple ketone, and the name of the compound is acetone. Then carboxylic acid functional group COOH. CO is carbonyl, OH is hydroxyl. Carbonyl and hydroxyl, both the groups are attached and act as a functional group, that is for the carboxylic acid. And R is alkyl group. Here alkyl is methyl. So CH3COOH, the name of the compound is acetic acid. Name of the compound is acetic acid. Then ester, functional group COOR. And here R is alkyl group is methyl group is given, that is methyl acetate. Instead of methyl, if you give a C2H, that is a ethyl acetate or propyl. So R may be ethyl, methyl or propyl, any one of alkyl group. Then ether, OR, and here this is also, there are two kinds of ether, simple ether, mixed ether. Here one example is given, that is going to be a simple ether, because either R are from the same alkyl group, CH3, that is a methyl. So 2 methyl is here, that is dimethyl ether. Because of the 2 methyl group, dimethyl ether. Suppose instead of methyl, if you apply ethyl C2H5, you can say diethyl ether. And suppose one side is ethyl, other side is methyl, mean we have to write ethyl methyl ether. According to the alphabetical order, E will come first, so we have to write ethyl methyl ether. Also these kind of examples already have learned in the 9th standard. So these functional groups and formation of compound from the functional group is important. So you have to go through. Instead of R, you can apply any other alkyl, ethyl, propyl, butyl. So you will get the butyl alcohol and the butyraldehyde. Also see that acetic acid, maybe propionic acid, ethyl acetate, and diethyl ether. So different kinds of compounds can be derived using the different alkyl groups. So you have to go through up to this. Only simple topic, simple portion, very small portion given. What is functional group? Functional group is nothing but an atom or group of atom in a molecule which give its characteristic chemical properties. And there are two portions in this organic compound. One is functional group, another one is alkyl group. Functional group define the chemical property of the compound. The remaining part define the physical property of the compound. This you have to keep in your mind. Then the tabular column it is given few examples of a functional group and the formation of hydrocarbon, alcohol or acetaldehyde compounds from this functional group. So you have to go through, prepare well, and the next topic, that is homologous series. Next topic, homologous series, that we will learn in the next session. So prepare well, don't waste the time, complete your classwork and also get ready for the test for the previous lesson. Thank you. God bless you.